Hi class, today we're looking at lesson 12.2, which is simplifying rational expressions. Remember, a rational expression or an equation has a variable in the denominator. And with rational expressions, oftentimes we can factor something out of the numerator and the denominator to make our expression look a little bit more user-friendly. So simplifying rational expressions, the key here is you want to make sure you're only factoring factors. And we'll go through several examples in class 2, but here's just a quick tutorial on simplifying rational expressions. So you want to look at your numerator and you want to look at your denominator and you want to factor them completely. And so if we look at our first example here, we have 4x minus 20 over x squared minus 9x plus 20. Well, if I look at my numerator here, I know I can factor out a 4. So I factor out a 4 and I'm left with x minus 5. Now the nice thing about rational expressions are, as opposed to just factoring cold like we did in chapter 10, is that you have hopefully some clues in your numerator that might help you factor your denominator. So in this case, when we start to factor our numerator, okay, we factor our numerator into 4x minus 5, and then we see that we also have an x minus 5 in our denominator, because our denominator factors into x minus 5 times x minus 4. So we now have factors. Remember, factors are things that are in parentheses. They're things that are multiplied together. So we can zap out or cross out our x minus 5s and reduce that rational expression to 4 over x minus 4. Okay, and now we have a simplified rational expression. Let's try another example. They won't all be as easy as that, but this is just a great example to kind of get you thinking about factors. So in our next example here, we can start to factor our numerator, and we see that we take out the 3 and we get x 3 times the quantity x minus 9, which is great, but our x's in our denominator here are reversed. So what you're going to do first here is you're going to, we factor out our 3 times, and then we get 3 times x minus 9. Well, when we factor our denominator, our factors are kind of backwards. So what we want to do is we want to take out a factor of -1 out of here. And what ends up happening with this, if you imagine this 9 minus x, if you were to take out a -1 from a positive 9, that gives you a -9. And then when you have a minus x, if you take out a negative, that actually gives you plus x. So we end up getting x minus 9. The signs kind of reverse here when we take out a factor of -1. And so now we have two factors that look identical here in the x minus 9s that we can cancel out or factor out. And then we're left with this -1 in the denominator and this 9 plus x. And with the commutative property, we can always reverse those addition problem. So 9 plus x is the same as x plus 9. However, x minus 9 and 9 minus x aren't the same, and so we have to take out that negative in order to make them look the same. So then in order to finish simplifying this, I bring that negative up with the 3 because we always want to keep our negative signs in the numerator so they don't get lost. And then our denominator is 9 plus x. You could also write that as x plus 9 and you'll be fine. And so we took out a -1 to make our factors match, and then we divide out our negative x minus 9s. Okay? So if we look at the next example here, here's a word problem, and everyone says, when am I going to use these in the real world? Well, here you go. So the baking time for bread depends on the size and shape, and a good approximation is this formula here for a cylindrical loaf. Okay, is 60 times the volume divided by the surface area. Well, we now start looking at our surface area formula, and our surface area is going to be the radius plus the height. Now, wait a minute. Where the r is radius and the h is the height of our loaf. Find the baking time for 8-inch long that has a radius of 3. So we can plug in our numbers here into this formula, But more specifically, I'd like you to think about where that formula came from, okay? So here's our formula. We have 30 r times h over r plus h. And so mathematically, if we just use our simplest formula here, we have 30 times 3 times 8 over 3 plus 8, which is 720 divided by 11, which is about 65 minutes. Okay, so that's how we use that formula, but I would like you to think about the volume and surface area formulas for cylinders. Does anyone know what they are? Think about those. Maybe you want to grab your assignment book and look it up. I am jumping to another page here, so we're going to add a page. So we have, the formula was 60 times, go back to the formula here, the volume over the surface area. And we're talking about a cylinder. 60 times the volume over the surface area of a cylinder. I apologize for the messiness of this, but think about the formula for volume of a cylinder. Does anyone know what it is? It's actually pi r squared h, where h is our height and r is our radius of our cylinder. Now the surface area formula is a little bit more complicated, and if you look it up in your assignment book, you're going to get the formula 2 pi r squared. Okay, that's going to give us the area of our top and our bottom, because pi r squared is the area of a circle, and we've got 2 of them in our cylinder, plus we need to find the lateral area, the area of our side, and that is 2 pi r, which times h. Okay? So now think about that. This formula looks a lot different than the simplified version that they gave us. Well, let's start to factor and see what happens. What I'm going to do in my denominator here is I'm going to factor out. I still have the 60, and then I still have times the pi, and then I have my r squared and my h in my numerator. But my denominator, okay, I'm going to start to factor here a little bit. In that, I'm going to take out a 2, and I'm going to take out a pi, and I'm going to take out an r out of each term in my denominator. Okay? So when I divide this by 2 pi r, I'm left with r, because that r squared is the only thing that's not factored out. Over here, if I divide this part of that surface area formula by 2 pi r, what am I left with? 2 pi r, I'm just left with the h. Okay? So now, what is 60 divided by 2? That's 30. Notice how I have a factor of pi here and here. And this becomes, okay? And then I have an r squared. What is r squared over r? That reduces to just a plain r. And then I have nothing to factor out my h with. And remember, this h here is not a factor. This h in the numerator is. So I have that h. And then my denominator, I'm left with r plus h, because everything else is factored out. Pretty cool, huh? And that's where they get the formula from. So if you have some questions about that, I'll do that again in class. Just ask me about it at some point. Go ahead and try the quick checks on the next page in your notes, and I'm going to show you the answers now. You can pause this if you're working on your quick checks. So in our first quick check here, we have we have 12c squared over 3c plus 6. So I'm going to factor out a 3 in my denominator, and what ends up happening is that 3 and the 12 then factor out, and I'm left with 4c squared over c plus 2. Here in B, I factor my numerator, and I get c minus 3 times, and it should be c plus 2. I started to use my x's here because my c's were looking bad. And then in my denominator, I have x plus 2 and x plus 3. Well, I have two x plus 2's that I can factor out, and I'm just left with x minus 3 over x plus 3, or c's if you use c's. In example 2, these are great examples of where we have to factor out our negatives. And so in my denominator, I factored out a -1 to make it look just like my numerator factor. Now that I have two identical factors in my numerator and the denominator, I can cancel those out, and I'm just left with 1 over -1, which is essentially -1. In example B here, I factor out a -4. I kind of did two steps in one there. So I factor out a -4 so that I can reverse my product here, or in this case my difference. I can reverse my difference, and I now have a factor that looks like the factor in the denominator here. And so when I cancel those out, I'm left with -4 over r plus 4. All right, in example quick check 3A, it asks you to use your formula to think about how long it's going to take to bake a 4-inch with a 3 radius loaf of bread, and using that formula here, you get about 51 minutes. Critical thinking is what I explained to you, and here's another mathematical typed out a little neater for you. Here's a mathematical process for that, and that was also explained right after I did example 3 in the notes. Please write down your questions, send them to me, or ask in class. Thanks.